Hi, welcome. In this video, we will solve problem set matrix zeros asked by companies like Amazon, Microsoft, and Apple. Welcome back to one another video. Let's solve today's problem set matrix zeros. Okay, one of the very good problem on 2D arrays. Okay, let's see. So given a m cross n integer matrix, if an element is 0, set the entire row and columns to 0. So you can see in sample input, okay, here we have 1 0, okay, on second row and second column, okay. So the entire row, this entire row and entire column is now 0, okay. So we just need to do this and we need to set the entire row and entire column 0 to solve this problem, okay. Very clear, okay, very understandable problem, okay. Let's see how we can solve this. Let's see now what are the different approaches that we can apply. Okay, so let me create a one good test case. So let's see. So let me take 1, 2, 3, 4 and 1, 5, 5, 0, 7, 8 and 0, 10, 11, 12 and let's take 13, 14, 15 and let's take last number 0. So if I make the entire row and column 0, what will the sample output? Let's quickly construct it, our sample output. So the entire row will be 0, entire column will be 0. Here the entire row will be 0, entire column will be 0. Here the entire row and column will be 0. Okay, so now only one number left will, that is 3. This will be our output. Let's see how we can solve this problem. Okay, so this is our matrix, n cross m matrix. So how you can solve it? Okay, so you have a 1 0 and you need to make the entire row and entire column 0. Okay, let me copy this. Okay, and this is my answer. So what can one approach can be that I will simply iterate through each element. Okay, I will iterate through each element like 1, then 2, then 3, then 4, then 5, and whenever I am getting 0, what I will do, I will make the entire row and column 0. Okay, but if I'm doing this, so if I'm doing this, so let's see. So you got 1, okay, you simply leave it. You got 2, you will simply leave it. 3, okay, let me copy this one. Let me get a copy of it. Yeah, so suppose here I got 1, that's okay. 2, 3, 4, 5. Now I got 0. What I will do, I will make this 0. Okay, let me use the same color. 0, I will make this 0, I will make this 0 and I will make the entire column 0. Okay, like this. Let me remove. So I will make like this, all zeros. Okay, now you will again iterate. Okay, you will traverse. Here you are also getting zeros, right? And how you will differentiate between the 0 that is given and the 0 that you have created, that's the problem. Okay, so these zeros that you have, these are the zeros that you have created. Okay, these all are zeros and this was the 0 that was already given. This 0, this was the 0 that was given. This is the 0 that is given. This is the 0 that is given. You don't need to make this 0, otherwise entire matrix will become 0, right? If you are taking this 0 also in consideration, you just need to convert those zeros that already given. So how you will differentiate it? So for this one try that we can do, okay, so you can see here. So we have 1 2 3 4. Let me quickly write it again. So we have 1 2 3 4 5 0 7 8 0 10 11 12 13 14 15 and 0. So instead of creating 0, instead of creating zeros, what I will do, I can create any other number. Okay, I can create any other number or any alphabet. Like suppose is this is 0, what I will do, I will create an X, right? So let's make the entire row and column be X. So this will be X, this will be X, this will be X, this will be X. Okay, and here it is X, so I will leave it. Here it is X, I will leave it. Again I am getting 0, so what I will do, I will make the entire row X and entire column X. Okay, then I will like here I will leave this, here I will leave this, here I will, this is 15, nothing to change. Here it is 0, so what I will do, I will make entire row and column X. Now once I have made the entire row and column X, right, basically what I will do, suppose this is my n cross m matrix. Okay, what is the name of it? Suppose name is matrix. Okay, what I will do, I will simply say matrix of I comma j in traversal. I will make this X. Okay, and once I have done it, what I will do, I will reiterate, I will again iterate in the matrix, I will again iterate in the matrix, and wherever the we have X, okay, I will simply change it to 0. So I will say, like, I will change it to 0. This will be 0, this will be 0, 0, 0. All this will become 0, right? And we will get the same answer. We will get the same answer. Yes, this is one try that we can do, and yes, this is easily achievable. Okay, we can simply do so this will be one approach that we can do. Let's quickly try to write the pseudocode of it. Okay, so what will be the code of it? So what we are doing basically, okay, let me remove this one too. Okay, or let me simply create one copy of it, and let's now write the code. So for this, let me short a bit. So for this, what will be the pseudocode? Basically what I am doing, I am traversing in my matrix. So I will start from 0 to, suppose we have n rows and m columns, right? So I will traverse to n. Okay, and I will write j will also start from 0 to m. Okay, and if I am getting 0, right, like matrix I comma j, if it is equals to 0, what I will do, I will simply call function. So what I will do, I will create some functions, like suppose make x. Okay, make x, I will call this function. So there will be two functions, like one will create for row, like make row x. Okay, or let me create a short name of it, like mm, like row x, suppose change in a row. So I will call row x and column x, and in row x what I will do, I will pass the row. Okay, and in column x I will pass the column. And is there any other thing that I need to pass? No, so I will simply close it. These are the functions. What will be the functions? So suppose I have one function, it is a row. Okay, let's take I, and what I will do in this function, okay, I'll simply run a for loop, because I want to make the entire row, right, this row. So I will start from 0, okay, to like n rows, m columns. So I will run till m. Okay, and what I will do, I will simply say matrix of I, this I, right, this I, this is also I, so let's change it variable. So instead of this, let's make it x, right? So I will say x. Okay, x, and this will be I, make it X, capital X. Okay, I am marking X. Same function row X. Now here also in this function, what you will do? You will call column. Okay, let's take the same variable X here, column X. What you will do? We'll start from again 0 to n. Okay, and you will make matrix of I comma X equals to capital X. Okay, so you will make the entire column. Okay, X, you will make the entire row X once this step is done. Okay, once this step is done, let me shrink the size bit. Once these two steps are done, we'll write one more function where you will again reiterate. So let me copy the same function. Again you will traverse. Again you will traverse. And what you will do, you will find X that you have marked. So you will find X if matrix of I comma j is equals to X. What you will do, you will simply change it to matrix of I comma j equals to 0. Right? So this you will done, and this will be your approach 1. What will the time complexity of it? So this loop will run for n times. Okay, one side loop will run n times. Total will run from n cross m times. Okay, this is running for m times, this is running for n times, and this is inside it. Okay, but this will be like n cross m. Okay, then what I will do, I will multiply this into n plus m. Remember, this will be n plus m because this is one function. Okay, this is one function, not one function is inside row of X, is not inside column of X. Okay, so n into m plus this is also will take time, same amount of time, n cross m. Okay, so what will the total time complexity? Total time complexity, if I add the n, so like it will be like n square plus like nm 2nm plus m square plus nm. Okay, it will be something around nearly. Okay, it will go around, like if you ignore the constant, so it will be big of, like if you take n is nearly equals to m, then it will be n square plus n square plus 2n square, something around, let me write it, n square 2n square 3n square 3 plus it will be nm, so 3n square plus n square, something around 4n square. If you ignoring constant, it will be around big of n square only. Okay, but again we have a very large number, 4 into n square. Okay, so it will be very huge, although the time complexity is quadratic, that is big n square only, but it will be very huge because we are multiplying by 4. Okay, so it's a huge time complexity. Okay, is there any space that we are taking? No, we are not taking any space. So the time complexity will be big of n square, space complexity will be big of 1. We need to improve it, right? We need to improve it. We need to come up with a better solution. Okay, how we can improve this? Okay, even if it is n square, right, we will, so we are running in a matrix, we are traversing in a matrix, so the time complexity will be big of n square, but it is in a multiplication of 4, right? You can see the constant is too large. We will try to decrease it, we will try to decrease it. Okay, it can be nearly equals to big of n cube, right, for a certain values. Okay, so we will check it, we will try to reduce it, and what will be our next approach? So what we will do, again let me take a quick the same example, 1 2 3 4. So let's see here, we come up with any other alternative approach. So again, what we were doing in the previous approach, we were taking, right, we were checking each element one by one. Okay, traversing, and then we were finding if there is an 0, we were changing in that time. That's why the time complexity increased, right? That's why the time complexity increased. So yeah, here there is one thing, okay, if n and n it will be n square, and n plus m it will be 2n, right? So n square into m it will be around n cube and n square, okay? No, not for this, okay? It won't be around n square, it will be n cube. How? Basically, if n is nearly equals to m, okay, it will be n square, and n plus m it will be 2n. 2 into n square it will be around 2n cube plus n square, and if you are taking the higher order term it will be around n cube, okay? So the time complexity of this approach will be order of big of n cube, which is very high, okay? And space complexity will be around big of 1, okay, because we are not taking any extra space, okay? Sorry for that mistake, I just checked it, right? If n plus m both are equal, it will be 2n, and 2n into n square it will become 2n cube, okay? So this will be the time complexity, and so this was the error, or this was the problem, I will say. This changing here, it was taking time, right? Because I'm calling this function, this is also taking n times, okay? This is also taking m times. So these functions inside my n cross m, right? Inside my n cross m, these functions is making too much time, right? This is taking time, again iterating. So what we need to do, we need to think that instead of changing 0 in that time only, okay, we will come up with some better approach. So what we will do, here I got 0, I won't change it directly, I won't make it 0, I won't make it 0. What I will do, I will create one array, right? I will create one space. So let's create one space here, okay? Let's array, and I will mark the index, or you can say I will mark the column or row of it, okay? So let me quickly create it. So this will be my column array, or you can say this will be my row array. What I will do, I will simply mark it, right? So suppose I filled with all these zeros, okay? I will fill with all zeros, okay? And I will simply traverse in my matrix. So this is 1, okay? 2, 3, 4, no problem. 5, 0. Once I get 0, okay, I will mark the column and row to 1. So this row and this column, I will mark it with 1. That means here we got 0, this row and this column. And then again 7, 8, no problem. 0, I will mark the row and column to 0. So what I will do, I will mark the row and column to 0, to 1. Sorry, this will be 1, this will be 1. Okay, then again what I will do, I will simply iterate. So 0, 10, 11, 12, 13, 14, 15, 0. Again what I will do, I will mark the row and column to 0. So this 0, this 0, what I will do, I will mark with 1. Okay, I will mark it, and once I marked it, right, row and column, now I have this row and this column. What I will do, I will simply change it now. Again I will traverse, okay? And suppose I am traversing this element, okay? I will check, is the column is 1? Yes, it is 1, make it 0. I will traverse. If the column is 1, yes, 1, make it 0. I will traverse. If the column is 1, no. If the row is 1, no. So leave it. So the number was 3, so I will leave it. I will again traverse. Is the column is 1? Yes, make it 0. Is the column is 1? Yes, make it 0. If the column is 1, make it 0. Right, either column or row. Here, is the column is 1? No. Is the row is 1? Yes. Row is 1. So again make it 0. Here, is the column is 1? Yes, make it 0. Is the column is 1? Yes, make it 0. Column 1, make it 0. Column 1, no. Now let's check row. Yes, row is 1, make it 0. So this is how I will make all 0, okay? And I got 3 only number, and this is how we can reduce the time complexity, okay? Because we are creating a separate column and separate row for it. Okay, clear? So what will be the pseudo code of it? Let me write the pseudo code of it. So let me write the pseudo code of it. Okay, so what I will do, I will first create one column. Okay, column of size that will be m. Okay, m column, n rows, right? So I will create a column like suppose new array of size m, and I will fill it with 0. Okay, I will create one row also same new array of n size, and I will fill it with 0. Okay, basically this is how I will create one row and column. Okay, once I created, I will simply traverse. So I will start from 0 to n, and then I will start for j equals to 0 to m, and then what I will do, I will simply check if, okay, if my matrix of I comma j is equals to 0, what I will do, I will simply make that row of I equals to 1 and column of j equals to 1. I will make it 1, right? I will make it 1. Once I make it, this is done. Okay, the next code it, because you have changed it. Okay, now again you will traverse in a matrix. So I will again traverse for I equals to 0 to n. Okay, for j equals to 0 to m, again I will traverse. And now what I will do, I will check if my row of I is equals to 1, or this is 1, or column of j if it is equals to 1. If these two conditions are done, okay, if these two conditions are done, what I will do, I will simply make matrix of I comma j is equals to 0, and that's it. In the last I will return the matrix. So now what will the time complexity of this approach? Here what I am doing, I am simply creating one array of size m and n, okay, filling with 0. Now this will run for n into m, and this will also run for n into m, but both are separate. So n into m plus n into m, okay, and that's it. It will be 2nm, okay, and if I say n is nearly equals to m, so what will the time complexity? It will be 2n square. Okay, so the time complexity here will be order of n square. In the first approach, the time complexity will be was n cube, right? The time complexity here will be n square, and space complexity will be, I am taking n space and m space, right? If I am taking n and m both are equal, it will be around 2n space. Okay, 2n space we have created. Okay, but yeah, this is one way that we can solve this problem. Okay, very simple problem. Okay, just we have created one column array, okay, and row array, and by this we have solved it. Okay, so this is how we can solve it, by pre-computation, right? Instead of changing the elements on right away, okay, there itself, I'm storing it. I'm simply storing the indexes where it is the change, where I need to change it later. Okay, so I'm storing it. So you can see pre-computation I'm using here. Okay, now is there any better way? Okay, this was the better way, right? We changed from n cube to n square. Now is there any better way? So how we can make it better? Because we are traversing in matrix, so it will take big of n square. But yes, is there any way that we can reduce the space complexity? Can we reduce the space n? Okay, so yes, we will try. How? Let's look into approach 3. So let me fill these elements. So yes, how we can make the optimal approach? So in the last approach that we have used, what were the thing that we were doing? We were taking space, right? This row we were taking. Okay, let me create one more example of it. So basically I have created an array, right? I have created an array here, something like this. Okay, for row and for column. If I want to decrease the space complexity, right? If I want to decrease the space complexity, I don't want to take this space, can we use the same row? I'm talking about this. Can I use the same row and same column? So if I'm using the same row, let's see. I'm using this row. I'm talking about this row, okay, and this column. Here there is one thing, right? There is an overlap of, let me remove all these things. Here is one overlap of one element, right? Here the row, this is getting overlapped, right? So either what you can do, you can create your own row. Either you can take this one or this one. So basically I'm talking about this one. Like here you have this array and here you have this as a column. Here you are using this as a row. So here that is one section that is common in both of it, right? So how you will differentiate, right? How these will contribute to the same thing. So what you can do, you can, for this you can create, this, you can create one variable, because you just need to fill one, right? So suppose this is for one column, this is for one column, this is for one column. For one array you are creating, suppose column 0, like this, column 0. Okay, so it's something like, you can understand it like this array. This is your array. Okay, you are using column 0 to fill it. Okay, so basically your one variable that is responsible for column 0, that is currently now 0, you will mark it 1, or you can mark it 0, or like in the later you can mark it 1, right? So suppose let's mark it 1 only. Okay, so I'm starting with 1. Once I will get 0, I will mark it 0. So this, just I'm telling you that this is how you have one row. Okay, and this is your one column. So we are not taking any extra space, we are using the same. In the space we are using only single variable. Okay, and how I will do it, what I will do, I will do the same. 1 is there, no change. 2, no change. 3, no change. 4, no change. I got 5, no change. 0. What I will do, I will change, let me use green pen, I will simply change that column, right? So this is column, like this is a row. For row I will simply change it, and I will change it here. 7, no change. 8, no change. 0. So this is already changed, nothing to do it. Okay, and I will mark column 0 as 0, because this is representing my column. So I will mark this as 0. Okay, again 10, no change. 11, no change. 12, no change. 13, 14, 15, no change. 0. I will mark this as 0, and I will mark this column, right, this as 0. So these are the things that I am doing inside the matrix. These are the things that I am doing inside the matrix. Okay, once I have done it, what I will do, I will iterate. Okay, but how I will iterate, that's the thing. Okay, should I change this one? Like here column 0, should I start from this one? Should I change first the array that I have created? No, because these are the spaces that I'm using to change the values, to change the zeros. If I'm simply manipulating this first, so I will simply lost track of all my zeros that I have created. So I won't change these, right? I won't change this column and this row at first. What I will do, I will change all the rest of the elements. That means I will start from here. Okay, so this is 0, simply leave it, nothing to change. This is 7, let's check, is the required column is 0? No. Is the required row is 0? Yes, make it 0. 8, is the required column is 0? Yes, make it 0. 10, is the required column is 0? Yes, make it 0. 11, is it 0? No, but row is 0, so make it 0. 12, is the required column is 0? Yes, make it 0. 14, required column is 0, make it 0. 15, row column is not 0, but yes, this row is 0, make it 0. 0, no change. Now see, once you have done it, right? How, like, we need to change this one, right? But we will discuss how we will do it. Now, once you have done it, should you have things to do, right? First or second part, right? Which you will do first? Or let me not put it first and second, let me say A and B. This is A and this is B. So will you change this column, right? That column that you have used this first, or this row that you have used this first? So see, if you are doing, if you are going with A, right, you have column 0. Okay, what you will do, you will change this first. You will change, like, suppose if you are changing this first, okay, it will affect the B result. How? Because you will make this 0 and you will determine this position by this, right, by this column. Okay, so it will change the position. So what you will do, you will first do the B part. You will first do the B part, because for changing B part, okay, this is like, if we change the B part, our this array won't be affected. Okay, let's see. So what I will do, I will simply check. This is 0, nothing. This is 3. Is the, okay, there is no column. Okay, there is no above any column. Is the row is 1? Or if the row is 0, no, it is not 0, so we won't change it. We won't change it. We won't change it. Okay, here 0, nothing to do. Okay, no change. Now what I will do, now I will check this one. Okay, now let's check. We have 1. Is the column is 0? Yes, make it 0. Now this is 0, this is 0, this is 0, nothing to change. Everything is already done. Okay, so this will be our required answer. Okay, suppose if you are doing A part first, okay, what you will do, you will check column 1 is, column 0 is 0. Okay, so what you will do, you will simply make this to 0. And once you make this 0, if you are checking, okay, for 3, is the required row is 0? Yes, you will make this 0 and you will end up creating all zeros. So what we will do, we will do B part first. Okay, we will do B part first. We will first check for this row. Okay, we will check 0, 3. Is the required row is 0? No, it's not. So then you will check the A part. So remember, we will first do B, then we will do A. Okay, so this is how we will do. Okay, what will the code of it? Okay, so in the next video, I will show you the code implementation of it. Okay, and we will discuss the time complexity later. We will discuss the time complexity later. Okay, so in the next video, I will give you a code implementation of it, how you can implement the approach that we have discussed. So let's see you in the next video.